Well, hello friends, and as we get started with this particular lesson on some of the properties of integrals, we are going to look at some of the more important ones that result from dealing with integrals. So let's start with this information that you see in a big box on your notes involving the different properties. Now, the order of integration, if you go from A to B, or B to A rather, in this case, you notice that the B is down here and the A is up here. You can simply switch the order of integration, but it'll cost you putting a negative sign in front. So that's a pretty straightforward thing. It's almost like the idea of kind of working backwards when you go to do your integration. Now, this next one, the zero property, is one of those that'll sneak up and get you if you're not observant, because if you're going to find the area underneath a curve and you're going from A to A, well, you're going to have zero width of your rectangle at that point. So as a result, the value of the integral will be zero. Okay, now this next one, the old constant multiple rule, we've seen that a couple of times, and it's just this idea that you can take any constant and pull it out in front of a calculus symbol, and that way it sort of makes the problem a little bit easier to work with. So it'd be k times a to b, definite integral of a to b from f of x dx. And you could do the same thing with negative signs as well. You just pull them out in front, because it's like a constant of -1 instead. All right, now another little sneaky trick is that if you wanted to do a sum and difference of two integrals, you certainly could just by separating them out into two separate problems. And that works for derivatives and limits, as we've found as well. So, good properties to know for sure. Okay, now here's an interesting little property, the additivity property. And if you were to take the definite integral from A to B and the definite integral from B to C, and you were to add those two together, it would be the same thing as taking a definite integral from A to C of the same function. Now keep in mind that we do have to have the same function on both parts in order for this to occur. Okay, now these last two properties here are not necessarily going to get a whole lot of airplay, but they're kind of nice to know. And that is that if the maximum value of f and the minimum value of f are maximum and minimum values on A to B, then the minimum value times B minus A and the maximum value times B minus A, that is going to lead to the value of the integral being in the middle of those two. Could be equal, but definitely in the middle. And then this domination property says that if f of x is greater than g of x on a certain interval, then its integral is going to be bigger than that of g of x along the same interval. And if f of x is always greater than or equal to 0 on that interval, sort of like a corollary here, then that's definitely going to be the case for the integral as well. All right, let's put some of these properties into action with some problems that you might see on a free response question, or even like a multiple choice question or something like that. Now, suppose that we go from -1 to 1 of f of x, and we know that integral is valued at 5, and we go from 1 to 4, and that value of the integral is -2. And then notice we've got from -1 to 1 of h of x, a different function, completely different than f. This is h, and its integral value on -1 to 1 is 7. So what we're going to do is we're going to see if we can come up with the values of each of these integrals. And if we can't, then we need to come up with a reason why we can't do that. So let's start with a here. And as we look at a, we notice that the limits of integration are reversed from those of the one that we have there. So all I can need to do to solve this is no serious calculus, no graph needed, because we really don't know what's up with this situation. But we do know that if we just take the negative, we're in good shape because of switching the order of integration. Okay, now for part B, we go from -1 to 4 of f of x. And we know from -1 to 1, and we know from 1 to 4. So what we can do is we can use that additivity property to come up with the value of the integral overall. So from -1 to 1 it's 5, from 1 to 4 it's -2, grand total should be 3 when it's all said and done. All right, now for part C here, it looks like we've got a couple of different things at work here, and we've got a constant multiple times f and a different constant multiple times h. So this is sort of like saying 2 times from -1 to 1 of f of x dx, and then 3 times from -1 to 1 of h of x dx, and we know that's going to be 2 times 5, and then 3 times 7, because those are the values of those integrals respectively from up above, and 31 when you add it all together. All right, now we're going to run into some interesting situations down here at the bottom, starting with D. And you notice that the definite integral goes from 0 to 1. Okay, now it's a very dangerous thing to just automatically assume anything in mathematics. It's a very, very dangerous thing. You should really not do that if at all possible. Here's one of the reasons why. If you look at the definite integral from -1 to 1, it does get valued at 5. However, the problem is we're only going from 0 to 1. We don't have any sort of information about how this function behaves in any way. So it is not possible to figure out the value of this integral because we do not know how f behaves on 0 to 1. Okay, now here's what I mean by this. I mean, think about it. If the value is positive, we could have a whole bunch of area above the x-axis and some below that nets to 5, or, in some way, shape, or form. So if you cut the interval in half, you still don't know where that area is. It could be above, it could be below. All right, let's go on to part B here. And if you take a look at part B, it talks about this idea of from -2 to +2 of h of x. Now, once again, we know from -1 to 1, so you can't just double, because if you did, you would be running into kind of the same scenario that we were talking about. We don't know how h behaves outside of the interval, so not possible. We don't know how h behaves outside of -1 to 1. We just don't know what that information is. Okay, now this last one here, letter F, I mean, we could do this first part because we already did it in part B. The problem is we have no further information on h other than what we see right here. And since we're going from -1 to 4, I don't know how h behaves. And for the same reason as part E, this too is not possible. And the reason why is we don't know how h behaves outside of that particular interval. Try not to use an arrow like I did in your example. Sorry about that. Okay, folks, so that is a quick introduction into the properties of definite integrals.